Hi everyone, this is Miss Afric here. Today we're going to be talking about multiplying and dividing rational expressions. So we've been talking about rational functions this chapter, like graphing them, things like that. So I know we know that rational just means fraction. Alright, well today we're going to get into the real cool part about Chapter 9, which is actually getting to do some things with rational expressions. Today we're going to be multiplying and dividing. Later you're going to be adding and subtracting and solving equations. And by the end of this chapter you're going to be experts at anything fractions. I can almost guarantee it. Okay, real quick before we get into the harder problems, let's remind ourselves what we do with fractions that are just involving numbers. Okay, when we are multiplying fractions like in this first one, 2/3 times 4/5, remember to multiply fractions, we just multiply straight across. So I would multiply my numerators, 2 times 4 is 8, and then I would multiply my denominators, 3 times 5 is 15. And if I could reduce this, I would, but that is completely reduced, so there's my answer. Alright, in this second problem, notice how we're dividing. And remember, we don't ever like dividing by fractions. It's not a fun thing to have to do. So instead, we're always going to want to try and turn dividing into multiplying. And the way we do that is by multiplying by the reciprocal. And I'm sure you remember hearing that before. Okay, we always want to use that reciprocal instead of dividing by a fraction. So this would look like instead of 6/7 divided by 3/4, it would be 6/7 times, and then the reciprocal of 3/4, which is 4/3. So then once again, now it's multiplication. We just multiply straight across. 24 divided by 21. But wait, before we count this as our answer, we should be able to reduce that by dividing both of these by 3. So we end up with 8/7, and there's our answer. Okay, these are going to become key ideas when we start doing it with expressions. So it really does help to understand the basics before we move on. That way we'll kind of know where this is coming from. Okay, one more thing I want to review real quick before we start the complicated problems is factoring, because factoring is going to be a big part of multiplying and dividing rational expressions. Okay, so we've got kind of a bunch of different ways to factor it, to factor anything for that matter. Remember that GCF, that stands for greatest common factor. So if every term in your expression has a common factor, we would want to factor it out. Straightforward, right? Difference of squares, let's give you an example of that. So like if I said 9x squared minus 4. All right, 9x squared is a perfect square, 4 is a perfect square, and we're subtracting. So we can factor this out simply by taking the square roots of each term. Square root of 9x squared is 3x. That'll go in front. Square root of 4 is 2. And then 1's always a plus, 1's always a minus. Okay, trinomial, when I say that, that just means 3 terms. So for example, something like this. 3 terms right there. Alright, we factor it in a similar fashion, at least to start. It'll be factored into 2 binomials. And then you can kind of use guess and check. You can also kind of recognize, in this case, it should add to your middle number and multiply to a times c. In this case, a is just 1, so it just should multiply to 12. This should end up being x minus 4 and x minus 3. Okay, some stuff that you may not remember because it's been a while. Sum and difference of cubes. Okay, we have formulas for that you will have to know for this section. So if you don't remember, go back and check out those videos. Chapter 6. Okay, an example, sum of cubes. We first factor out just the cubed root of each. So x plus 3 is the cubed root of each. Then we'll take that first term and square it. We'll take both terms and multiply them together. And we'll take the last term and square it. And then our signs should always be same, opposite, always positive. SOAP. Okay, and difference is pretty similar, just with different signs. Factoring by grouping, that's the one where we could have 4 terms, something like this. And we would just factor it out by grouping. So group them together, factor out our GCF in each group, and then factor out that common term that you see. Oops. There we go. Plus 1 times x squared plus 9. Okay, so that's just a very quick reminder of factoring. If you think you need a refresher, you can find these in the Chapter 5 and Chapter 6 videos, so feel free to take a look back if you want a reminder before class. Okay, otherwise let's move on and try some actual problems with these. Okay, like I said, we're going to be multiplying and dividing, so let's just start with multiplying first. Number 1, we've got 5x squared y divided by 2xy cubed times 6x cubed y squared divided by 10y. Alright, well, think back to those two problems we did at the beginning. When I multiply fractions, we just multiply straight across. So my first step here is just to multiply straight across. On top, that gives me 5x squared y times 6x cubed y squared, all divided by, on the bottom, 2xy cubed times 10y. Okay, once you've gotten to this point, you want to multiply everything you can, simplify it completely, and then we'll divide whatever we can. So on top, I can do 5 times 6, which is 30. X squared times x cubed, we should know we just add the exponents. So, oops, x to the 5th. And y times y squared, remember that's really a y to the 1st. So again, add those exponents, we got y cubed. And on the bottom, 2 times 10 is 20. Just an x, and then y cubed times y is y to the 4th. And from here, again, it's just simplifying, knowing our exponent properties, right? 30 divided by 20, that's 3 divided by 2. If I have x to the 5th divided by x, I subtract those, so I end up with an x to the 4th on top. And y to the 3rd divided by y to the 4th, I should end up with just a y on the bottom. And that's as simplified as I can make it. Alright, so when we just have these types of exponent type expressions, we simplify it the same way we always have. Let's try number 2 then. Alright, in number 2 it's a little bit different because we have actual binomials, actual expressions that we are going to have to factor. Keep that in mind. Okay. Now, one thing when we're multiplying rational expressions, remember rational means fractions. We would really like it if they were both written as fractions. So if there's ever one not written as a fraction, remember it's the same thing as over 1. The reason that's helpful is now we can do just like we did over here, multiply straight across. So let's do that. On the top, I have x plus 2 times x squared plus 3x minus 4. And on the bottom, x cubed plus 8 times 1, that's just x cubed plus 8. Oops. Okay, now with multiplying, and for that matter, eventually when we get to dividing, there are really two big steps that we're going to have to do once we've combined them like we have already. Okay, the first step is I always need to factor. And that means factor everything you possibly can in the problem. Alright, so in this one, x plus 2, well that's already factored. So I shouldn't have to do anything with that. But x squared plus 3x minus 4, that's a trinomial, so I should be able to factor that more. Alright, it needs to add to 3 and multiply to negative 4. So I know both of these have to be x's since it's just an x squared. Adds to 3, multiplies to negative 4. Most likely I'm going to need a 4 and a 1. If I want it to be added to a positive 3, this would have to be positive 4, negative 1. So there's the top. And in the denominator, we should recognize that x cubed is a perfect cube, 8 is a perfect cube, and we are adding them. So this is a sum of cubes. Yes, we get to use our awesome formula that I know we all remember because it's been so important in our lives. Sweet. Alright, so x cubed plus 8, that turns into x plus 2 times x squared minus 2x plus 4. Okay. So we should know, also remember back that if the sum of cubes or difference of cubes, this expression will never be factorable. So we know we're done factoring. So the last step after we factored is to simplify. And simplify, that would mean like find any factors that can divide and cancel out. So in this problem, I see an x plus 2 on top and an x plus 2 on bottom. When I divide something by itself, it just gives me 1, which means it cancels out. Alright, there's no other terms, other factors that do that. So that means everything else has to stay. So my final answer would be x plus 4 times x minus 1 on top divided by x squared minus 2x plus 4. Okay, now you can multiply this out, but you don't have to. So I'm going to do it just to show you, but just know that you don't have to. You can also leave it as is. Either one of those is acceptable. Alright, so that's multiplying, and these steps right here are going to apply with dividing too, so don't forget them. Alright, let's try some dividing examples. Feel free to pause the video if you need to jot these examples down. That way you're not trying to multitask, because I know sometimes that can be challenging for some of us. Alright, with dividing, you want to think back to what we did at the beginning of these notes. So look back to them if you need to remind yourself. Okay, when we divide fractions, dividing is the same thing as multiplying by the reciprocal. Okay, and if I can turn this into a multiplication problem, it'll be a lot easier for me. So let's do that. 5x divided by 3x minus 12 times the reciprocal of this. The reason that's so helpful is because we know how to multiply fractions. We just multiply straight across. So I've got 5x times x squared minus 6x plus 8 divided by 3x minus 12 times x squared minus 2x. Now we go back to those two steps from above. We're going to factor, and then we're going to simplify. Always those two steps. Okay, so up here, feel free to try it on your own if you like, but then just make sure you pause the video because I'm going to continue going through it. Okay, x squared minus 6x plus 8, that should factor into x minus 4 and x minus 2. Then on the bottom, 3x minus 12, well, I can factor out a 3, so I'm left with x minus 4. And x squared minus 2x, I can factor out an x, so I'm left with x minus 2. Then we move to the simplifying portion. So I see an x minus 4 divided by an x minus 4. I see an x minus 2 divided by an x minus 2. Do you find the other one? Because there is one more. It's kind of tricky to see sometimes. There are x's on both sides. That means those can cancel out as well. So actually, all we're left with in this problem is 5 divided by 3. So that would be our answer. Okay. Alright, hopefully we're doing good so far. Let's get through one more so that we can feel confident going into class tomorrow. Okay, in number 4, it's a little bit more complicated. If you ever have multiple expressions, it's still the same general idea. Just make sure you go left to right in simplifying them. Okay, we know that this 2x minus 3 is really over 1. So now I can go ahead and multiply these two fractions. X times 2x minus 3 divided by x minus 2 times 1, which is just x minus 2. Okay, then remember again, I never like to divide right here. So instead, remember what we did over in this problem. We multiplied by the reciprocal. So instead of keeping that second fraction as is, I'm going to multiply by the reciprocal. Now that I've done that, I can combine them into one fraction. So I've got x times 2x minus 3 times x minus 2, all divided by x minus 2 times 4x squared minus 9. Alright, I'm going to leave you to try and finish this one. Just remember our two steps. We haven't done them yet. So make sure you factor and then try and simplify, and we can compare answers in class the next time we meet. Okay, if there's anything from the video that's still confusing, make sure you go back and watch it again, or write down your questions so that your teacher can answer it in class for you. Okay, make sure you finish this one on your own. See you in class.